Okay. Now, let's go for the problem number 4.3. A two-dimensional velocity field is given. So this is the equation for two-dimensional velocity. I minus 2xy plus y into z in an arbitrary units. Now, at position xy equals to 1, 2, compute acceleration ax and ay. Now we have the velocity equation, right? And we need to calculate the acceleration ax and ay. How can we do that? We can take the derivative of v to calculate the ax and ay. Now, if we because this is a two xy direction, so we can use these two equations. Du, this is the equation. Du by dt equals to u delta u by delta x plus v delta u by delta y. So that's for along the x direction, okay? And we can also take another, because this is the u is the this part, right? And this is v part. Now, if we take the u part, yeah, if we take the u part, then that's the along the x direction. And if we take the v part, so the equation will be this. Now for this equation, you see, this is the partial derivative. U equals to x square minus 2y square plus x multiplied by delta u by delta x. So delta u means this one. If we take the derivative of this, so we should get 2x plus 1, y equals to 0, so x equals to 1, plus v equals to 2xy minus 2xy minus of 2xy plus y. So that means minus 2xy minus y multiplied by du by dy, du by dy. Now, if we take the derivative of these in terms of y, then we should get minus 2y, right? Minus y square equals to minus 2y. So that's the ax. And similarly, if we take dv by dt, we should get u multiplied by delta v by delta x. So the u equals to x square minus y square plus x multiplied by dv by dx, meaning if you take the y derivative, it should get minus 2y, right? Yes, plus v equals to minus 2xy minus y. So minus 2xy minus y multiplied by the delta v by delta y. So if we take the derivative of in terms of y, we should get minus 2x minus 1. That's the ay. So it says that at position 1 and 2, we need to calculate the x and a y. So if we put the value x and y equals to 1, 2, then you should get ax equals to this one, ax equals to, you put the value of x and y, you should get the 18i, right? And for ay, because it's in I direction, ax for I. And for ay, you will get, if you put the value of 1 and 2 in here, you should get 26j. So this is the value and this is, vector. So that's why you need to put the I, and for y part, we need to put the z, okay? Now for question number B, it says that the velocity component in direction theta equals to 40 degrees. So now we need to calculate the velocity component in direction theta equals to 40 degrees. So for part B, if we, at x equals to 1, y equals to 2, then the v from equation this one, v can be calculated like this. You put 1 minus 4 plus 1, right? So that means minus 2i minus, similarly, if you put the value of x equals to 1, y equals to 2, you should get minus 6a. So that's the velocity. Now, a unit vector, it says, you see the question, the velocity component in direction. So in direction of this theta equals to 40 degree, to calculate the velocity component in this direction, we need to find a unit vector, right? So to find a unit vector along the direction 40 degree line, we can write this equation basically. So that's the standard equation to write any unit vector in a particular direction. So n equals to cos theta I plus sin theta z. Now for theta, it says here it should be 40 degrees. So that's the unit vector, meaning the value of this unit vector is 1, right? And the direction is in that along that direction. So now if we want to calculate the velocity component in the direction theta equals to 40 degrees, we just need to take the dot multiplication of these two vectors. One is the v, that is this one. Another one is the unit vector. Now, if we take the dot multiplication, the value will be the same. It's just that we'll get the velocity component along this direction. Now, the v vector is this one, right? And the unit vector is this one. So if we take the dot multiplication, the calculation will have 5.39. Now we don't have any unit here given, right? So that's why it just written 5.39 units. So that's the answer for question number B. Question number C, it says that the direction of maximum velocity and the direction of maximum acceleration. Now, wherever you have the maximum acceleration, you will have the maximum velocity, right? And the direction will be also the same. So in question number C and D, it says the maximum acceleration is A max. So A max is basically AX plus AXI plus AY Z, right? So so basically the vector will be AX I AY J. So AX equals to 18I and AY equals to 26Z. So if you take the maximum acceleration, that is the value, right? So value will be root of, that's the, I think, standard equation, right? AX square plus AY square. So AX square equals to 18 square plus AY square, root of r. So you calculate this, that's the value. And the angle will be tan theta equals to root AY by AX. If you calculate this, you should get the value 55.3 degrees. That's the value for both, velocity and the acceleration.